Hey everyone, we're going into Unit 7, I guess, technically Chapter 8. I'll probably just refer to them mostly by chapters now, since we're a little out of order and people are getting mixed up. But this has all to do with polygons. So getting away from triangles for a little bit, though a triangle counts as a polygon, so you'll still see them a little bit. One of my favorite units. We're going to look at how to find the sum of the interior angles of a convex polygon. So a couple new vocabs and words in there, looking at convex, looking at polygon, interior angles, exterior angles, all of that. So yeah. All right, so vocabulary. It's been a while since we've had a lot of new vocabulary, but the first word is, of course, polygon. And a polygon is a closed figure with the following properties. Okay, it's formed by 3 or more segments that we call sides. They have to be line segments, so they have to be straight. They have to all connect together, so it's closed, there's no openings in it, and they can't cross over each other. So formed by 3 or more sides. Also, each side will intersect or connect with 2 other sides, one at each end. So that, again, goes to the fact that they won't cross over each other. It will only connect with 2 other ones, never more than that, and it has to connect with something. So if you have one just floating in space, it's not a polygon. If you have any curves, it's not a polygon. Okay. So examples of non-polygons would be like something like this would not be a polygon. Something like this would not be a polygon. So these are not polygons. All right. We can get even more specific in that sometimes we'll have what's called a regular polygon. A regular polygon is a closed figure, so it's still a polygon, where all the sides are the same length and all the angles are the same degree. So it's a polygon still. So it fits all the criteria from above, but it has all congruent sides and all congruent angles. And that's helpful because if we know 2 things are congruent, we can set them equal. Okay. Right, so which of the following are a polygon? Okay, so looking at the definition above, go ahead and pause the video and tell me which one of these is a polygon. Okay, so the first one is not, right? This is curved, so it's not a segment. Okay. This one would also be no. This line here has 3 intersecting points with this one, and this one, and it crosses over. That was one of the examples I even gave you above, so this one is not 3 points of intersection. This one is a polygon. All right, every point just hits once, all the sides are straight. We can classify this, which we'll talk about in just a minute. So that one is yes. All right, so there's a couple different classifications. Just like with angles, we can classify, or with triangles, excuse me, we can classify by like the angles themselves and by the sides. So there's two types when it comes to the types of angles that are in the shape. There's what's called convex and what's called concave. And you can kind of hopefully see the difference as you look at these. All of the concave ones have a point in them that caves in. All the convex ones do not. Right? So here, all the angles point out. Here, at least one angle is caving in. All right. Another way to look at it is all the line segments or all the vertices I spelled that wrong. Hold on. All the vertices can connect inside, where here something connects outside. So what I mean by that is if we were to pick a point, anyone, this is a vertex, okay, vertex of an angle where it bends, we could draw a line from there to every other vertex in our shape inside the shape. All right, we can do that with all of them. Oops, I did not mean to erase that. We can do that with all of the points. So that all of those are inside. Here, all of these are inside. Okay, all of these are inside. So everything is connected to everything else inside of the figure, and that would be true all the way across here. Where if we go down here, this one right here connects outside of the shape, right? Which means it has to have a spot that caves in. All right, so this is concave. All right, so you have one vertice at least going towards the center. Okay, so convex, concave. We will work mostly with convex shapes, but make sure you know the difference. All right, so every polygon has a name. 3 sides we know is a triangle. All right, tri meaning 3. 4 sides are quadrilaterals. And underneath quad meaning 4, underneath quadrilateral there are several shapes that classify as a quadrilateral, but they all are quadrilaterals. 5 sides are pentagons. So a lot of times a star is a 5-sided pentagon maybe. Or like a house shape would be a pentagon. 6 is a hexagon. You can see the word polygon, hexagon. 7 is a heptagon. 8 like a stop sign. 8 like an octopus is an octagon. 9 is a nonagon. 10 is decagon. 11 has a name, but I always have to Google it. It's not one you see often. 12 is my favorite word, dodecagon. And then you can have a dodecahedron when you get into 3D shapes, which is kind of cool. Anything else, including 11, that you don't see on this list, and sometimes ones that you may not remember the name, we can just call an n-gon. n being the number of sides that it has. And n will represent the number of sides that a shape has from here until the end of geometry. Number of sides. So for example, an 11 gon, a 13 gon, a 24 gon, etc. Realizing up here I need octagon, sorry, hexagon, heptagon, octagon. Anyways, so this is important to know because if I ask you a question about a decagon, you need to know that it has 10 sides. I will not give you that information. So make flashcards or whatever you need to do to remember what all of these means. Really, it's just like nine. Non sounds like 9. Octa, hopefully you think octopus, 8 legs. Hexagon, most of you know that shape. So you should only have a couple more to memorize that you haven't already seen before. Okay, so we're going to actually do this table in class. So if you're watching this video after class or because you were absent, then make sure you copy this table from someone because we're going to do an in-class activity that has to do with that. So moving into the last page. Once we know all of those all of the sums and the angles and being able to figure that out, then we can solve problems. So the sum of the measures of the interior angles of a polygon is 1800. Find the number of sides in the polygon. So we will have already developed the formula for this once again in class, where if you take n minus 2 times 180 is equal to the degrees inside a polygon. So interior angles, that's your formula. All right, so we know that our interior angles is 1800, so that means that n minus 2 times 180 is equal to 1800, and we can solve for n, which is the number of sides. All right, so we're going to divide both sides by 180. Oops. So n minus 2 is equal to 10, and n is equal to 12. So this is a dodecagon. 12 sides. So that means that if you have a 12-sided figure, which I don't think I can draw successfully here, then all of the angles will add to 1800. Okay. The measures of an exterior angle of a regular polygon is 30. Find the number of sides. So exterior angles are cool because no matter what, we can take those angles and reduce them down into a circle. And every circle has 360 degrees. So the exterior angles, no matter what shape, are always 360. So if the exterior angles of a regular polygon is 30, regular meaning all the same, then your number of sides times 30 is equal to 360. So we divide by 30, and n, once again, equals 12. So a decagon has 1800 on the inside, 360 on the outside. Another way to think of this is that one exterior angle in a regular polygon, since they're all the same, would be 360 divided by n. So if each of those is 30, then 360 divided by n is 30. That would get you to the same spot. But I just knew that 30 times n will equal 360 as well. Okay, so you can think of it either way. All right, so find the value of x. This is where your algebra comes in, and knowing the shapes. Show your work. So this is a pentagon. All right, so this has 5 sides. So the sum of the inside angles is equal to 5 minus 2. Actually, let's back up. Remember, it's n minus 2 times 180. So n equals 5. So we do 5 minus 2 times 180. Or you look in your table because you just filled it out. That's 3 times 180. I don't know why I put an extra. Sorry. And that's 0, 24, 3, 4, 5, 540. All right. So that means that the sum inside the shape is 540 degrees. Okay. So you have all of your angles equal to 540. All right, so you should have 5. 1, 2, 3, 4, 5 equal to 540. So combining like terms, I have 413 plus x equals 540. So x minus 413 on both sides. And x equals 7, that's 2, and that's 1. 127 degrees. Okay. So you would do a similar problem no matter what the interior angle sum is. Just remember that this was 5, and that's where this 540 came from. Okay. So you have to do 2 steps for those. You have to find the sum first, and then set up your equation and solve. And that's it. Have a good night.